Okay, so topic two, this topic, we are going to look at the data science process. In this particular topic, we are going to cover mainly two aspects. Understanding that there's a flow to the data science process and discussing the steps in that data science process. So basically, those are our objectives. And we did look at this, the 6 steps in the last lecture, the setting up research goal, retrieving the data, data preparation, data exploration, data modeling, and presentation and automation. Those were in general, we looked at those. But as you can see, there are so many more detailed explanations on each of those goals when it comes to the actual processes. So we are going to go into each of these steps and then trying to see if we can understand the details of these. So setting up the research goal, there are details of that, and then retrieving data, data preparation, as you can see, has more. Data exploration, data modeling has a bit less, and presenting. Mainly, these are a bit less because these will be covered again in more detail in specific topics later on. But data preparation, after this topic, we will not be sort of having a separate topic for data preparation, but we will be doing that as we go through every case, every different exercise. So in terms of data science process, those 6 steps that we identified in the first lecture, setting up the research goal is the first one. We also looked at the end of the first lecture, the why we need to understand the business and also why we need to understand the data. So both those business understanding and data understanding is part of this particular research goal. Retrieving data is flows from the understanding of the data, data preparation, exploration, data modeling, and then finally presenting and automating. So the first step, which is very important, and sometimes we overlook this particular step in not only in data science, but in also the normal academic research. We tend to overlook this because we are so keen on getting into the data analysis. We are so keen on looking at the data, getting our hands on the data, cleaning and doing all those things that we love to do. We overlook this particular step, but which is very important. If you don't have this step properly done, then you will face difficulties later on. So the step one, setting the research goal, has a set of things that you need to do. First thing is defining the research goal. What is the goal that you actually want to achieve out of this particular data science project? So what is your goal? So you have to spend some time with the stakeholders. You would have to spend time with the people, the business, the senior management, the operation level staff, and so on, to understand the actual research goal, and then trying to define that research goal. Once you have defined that, then you have to create what is called a project charter, and this is the charter that you have to follow throughout your the whole data science process. So you have to ensure that this charter is actually the sort of map or the guide in your data science project. So the charter will have at the beginning, it will have the clear research goal, which you have already defined, and then the project mission and context. Then how are you going to perform your analysis? So you have your research goal now, you have your project mission and context now, then how are you going to perform your analysis? So what at this stage, this may change, but you will have to identify, okay, what are the things that you're going to do with your data? What resources do you expect to use? And then what is the proof that this is an achievable project, or what are the proof of concept? So how do you know, based on what evidence can you say that this data project can be achievable? the deliverables and the measures of success. So what are the deliverables, and then how would you measure that this deliverable has been achieved, or what are the measures of success, and then the timeline. So that is your project charter. So just some basic sample here. Project title, start date, end date, the budget information, project manager, the objectives, success criteria, approach. So these there are different formats that can be given. So that is the first step. So when you finish the first step, you will have a project charter. So that is so once the first step is done, you will have a project charter. The second step is retrieving the data, and then in the case of retrieving the data, there can be two types of data. That is internal data that is available within your organization, from the actual organization, the business data or the whatever data that you have within your organization. The second is the second is the external data. So when it comes to the internal data, it is you will have to think of the data retrieval. Just give me 1 minute. So I was saying that in terms of retrieving data, two types of data, internal and external data. In the case of internal data, you will have to see how you can retrieve the data from the internal sources. And then also in the case of internal data, then you will have to see the ownership of the data, who has okay. Yeah, for internal data, you have to identify who owns the data, because data ownership is also an area that we have a lot of issues, especially when for data scientists, because we actually want to do analysis on the data. We really don't want to own the data, but people who owns the data doesn't really want to share it. So there will be conflicts there. So you will have to navigate through those differences. External data, mostly what we can do is things that are available publicly so in those cases, then we don't really have to worry too much about the ownership, because it's publicly available. If not, then you will be requesting people for the data, and then once you receive, you get the approval, you get the data, then again, in ownership issues will be sorted out before you actually start working on that data. Then in terms of external data sources, especially for the US and the West, there are some open data sites, and we are going to use some of these in our data analysis, because we don't have a lot of large data sets, so we will be using some of these. Data.gov is the US government open data source. And then there's an open data Europa.eu, that's the EU open data source. There's a Freebase, World Bank data, and then aid data, and then FDA open data. And there are a lot of others that we are going to look at as well. So once we get the data, the next is data preparation. And we all know that data will have errors. Data will have errors at different points. So we will have to actually prepare our data for the data analysis modeling before we get into that stage. So in the data preparation, we have three three parts, that is data cleaning, and then data integration and data transformation. We'll be looking at each one of these, what that means. Okay. So when we talk about data cleaning, errors from data entry, if we can identify those, then we will have to address those. Physically impossible values, there can be, because if we know the actual values that are there, say for example, age. Okay, so if someone's age is 500, then we know that there is something wrong with that. Okay? So physically impossible values we will have to address. Missing values, outer liars, spaces, typos, and then errors against the code book, because if we have a code book, then we know, okay, what are the codes that we can use, and then if there are errors in that. And then data transformation, we will have aggregating data, extrapolating data, derived measures, creating dummies, reducing the number of variables. These are all things that we can do. And then combining data, merging and joining data sets, set operators, and creating views. These are all things that we can do in data preparation. So when we talk about data cleaning component in the data preparation, when there are mistakes during data entry, if you identify those, then manual overrides or manual rules, you can use some code to identify data errors, and then based on that, you can say things, systems to actually sort of update those. But generally, manually we update. But if it is a very large set with many mistakes, then we may have to come up with a code to do that. Redundant white spaces, then we can use string functions, those different functions to actually get rid of the white spaces. Because let's say, for example, when we are doing the analysis, if a string has an empty white space at the end, each of the ends, and the normal string, then in the analysis, it will treat that as two different strings. So we will have to make sure that all those are removed. Impossible values, as I mentioned, things like age, so gender, these are things that we can manually overrule those ones. Missing values, we will have to either remove that observation, or we will have to replace that observation with something else. We will look into some of these in the next slide. Outer liars, in the case of outer liars, we will have to see whether it's a genuine outer liar or whether it's an error. So if it is an error, then we have to treat that either as a missing value. And then when treating that as a missing value, then we will have to either remove or insert and so on. If there are deviations from the code book, then we have to match with the keys and then use either we have to match with the actual ones, and then or we can manually overrule those. If there are different units of measurement for the same data, then you have to change that to the same unit. So you have to recalculate. And then different levels of aggregation, then you have to bring to the same level of aggregation. So say, for example, if one data set has got daily and the other data set has got monthly data, then you have to aggregate the daily ones into monthly ones so that you can actually combine the two together. So you have to bring it to the same level of aggregation. For example, when it comes to outer layers, so as you can see here, this is a single outer layer which is very far from that from all the others. And when you include that outer layer, you can see that this red the line is the line that actually includes that outer layer and draws a regression line. If you exclude that, that is the blue line is the regression line. So you can see the difference in that. So you will have to check whether this outer layer, is that a valid outer layer? And am I going to include that, exclude that? So that decision will be based on how much that outer layer is going to influence, or how much of a piece of data that piece of outer layer is. If it is an error, of course, you have to remove, and then you have to carry out this. Some of the others are just simply simple variables. Say, for example, good, bad, two values, but someone actually misspelled good with Godot or bad with an E. So these just you can change that those values, these 15 values into just good, and this one value into bad, and then those outer layers will be will not be in, so it will be within the range now. So that's two different things. Okay? So And when it comes to distribution also, we can see with outliers how the distribution would look like and the expected distribution. So again, how do you treat those outliers will depend on the actual data that you have and how you want to actually manage those. So in terms of missing values, there are different ways that we can deal with it. One is we can omit all the missing values. That's easy to do in terms of a data set. It's very easy. So there's one sort of command, you can omit all the missing values, but that would mean that you would be losing a lot of information, observations. If there are very few missing values and losing that does not have an impact on your data set, then that's an easy to perform way of doing it. You can set missing values to null. This is also easy to do. You can set it to null easily. However, some modeling techniques will not actually allow null values. So it will not be able to handle null values. So you may not be able to always use null on the actual missing value. You can impute a static value such as 0 or some other value. That again, an easy way to do it, but it may lead to false estimations from the model because that value that you put in may not be, if it is a static value, that may not really give you the correct model. You can impute an estimated value. This does not disturb the model as much, so it doesn't really have that much impact on the model. But this is harder to execute. So getting estimation and then doing it. So you may have to make some data assumptions. Recently, we had one in last semester. We were actually having some data science assignments, and one data set we used was the weather data for the last 30 years weather data, and there were some missing values on the rainfall or temperature data, especially temperature data on some dates. The temperature data was missing. So what a lot of students did was they actually imputed the value that was closest to that. It may not be that accurate, but mostly the temperatures does not vary that much between 2 days, adjacent days, unless let's say you have a very heavy rainfall and then very sunny day the next day, then there may be, but generally that's not the case. So that will not have a major impact, but again, that will allow you to do computations and come up with a model easily without actually having missing values of that. The other is actually modeling the value, but that would mean that you are actually depending on the model, the actual model too much, so that the actual confidence of the model will be the missing values would be based on the model, so the model will have that impact on that. So again, depending on the size of the data set, depending on what how much missing values will have an impact, you can decide on what technique to use. In terms of deviations from the code book, we have talked about we can do the manual overrules, difference in units we can recalculate, difference in aggregations we can bring to the same one, and then it's always the advice is correct the errors as early as possible. So as soon as you see an error, correct that error. The next is in terms of data preparation is actually joining tables. So when you have two sets of two tables but same data, so client is the same client, but this table has got only the item and the month. This table has a client and the region, so you can combine the two with all the items in one table. So that is actually called joining the tables. The other is having two tables with the same data, but two different data, same attributes, but different sets of data. So Here, John Doe, Coca-Cola, January. This is John Doe, Coca-Cola, Zero Cola, February. So you can append the table one after the other so that you add the tables together. So it becomes one table. So that is appending tables. That's one. You can use views to simulate data joins. Again, here you are doing the same thing as appending. The only difference is that in this case, we are creating a new table based on this. In this case, you are not creating a new one, you are creating a view, which means this will not be permanent. This is a virtual table. So when you are finished, done, then this will not, it will not duplicate the data. There will not be a duplication of data. It takes data from these two, and on the fly, it creates a virtual table. You use it, and then again, any changes in the physical tables, the changes will be reflected here. But if you do this, then if you change this, let's say for this to March, this still will be January. So that's the difference between views and appending tables. You can also have aggregated measures like this rank is calculated based on aggregation of sales and these two values, that is 95 into 98, 215. This value is not, sorry, AX, this value is not correct, but still anyway. This is an aggregation sales by product class. So AX, so this is a multiplication of this value into, based on that we are getting this, and then based on that you are getting the range. So it's an aggregation of the actual values. The other is transforming the data. So this is the original data set, as you can see, X and Y. When you plot, this is what you will be getting. But if you take the log of X, you can see that the relationship between the two is almost linear. So there's no it's a linear relationship. So you can transform the data, but you're not really changing the data itself. You're just transforming it. So you're using the values to get a transformation of the data so that it's more meaningful when you come up with the relation. So the other is reducing the number of variables. When you have many variables to do a prediction, then the prediction may not be that accurate. So you have to check how many variables will be the optimum number. And based on that, you can reduce the number of variables. As you can see here, these two variables, component 2 and component 3, merge around here. The distance between that and these points are further apart, and then so when you take the two variables, it still gives you a good prediction. This will be total. I think this is 49% of the data based on these two components. But we will look at how we can select the number of variables and so on in future sessions. Finally, in terms of data transformation, we can actually create dummies because sometimes these factors in itself may not work as a single variable. So you may want to change that to male, female, so that you can do analysis separately for males, analysis separately for females using the variable itself. In which case you can just change male, female, and male. If it is a female, then that value becomes 0, female value becomes 1. So you are just creating dummy variables for this data set. The step 4. So once you have prepared the data, then the step 4 is data exploration. Data exploration actually looks at graphs, trying to see how the relationships are, or how the representations are, and so on. Again, we are going to go into more details on the data exploration as well as data visualizations. So we are not going to go into very much details. I'll just show you what these actually mean here in this particular lecture. So simple graphs like bar graphs, line charts, and those of you who have, you would know basically there are different types, histograms, so all these are simple graphs. And then combined graphs is when you have these simple graphs, two of those combined into one graph. This Pareto diagram is a combination of the values and the cumulative distributions of two together in one graph. So, and then link and brush is another type of data exploration which allows you to have the same data points represented in different different works, different observations, but emphasizing on the same data points. So that is link and brush. And then there would be others that we are going to look into. Step 5, data modeling. In the case of data modeling, we have 3 components that we are going to look at. That is the model itself, and then the variable selection. So what model are we going to select? Are we going to select a linear model? Are we going to select a regression, a classification? So there can be many things that you may be selecting. And then executing that model, and then once you execute that model, diagnosing that model to see how good that model is performing. So 3 aspects that we are going to look at in terms of model data modeling. So in the case of data modeling, the first part, selecting the variables that you want to include. So we have to do an exploratory analysis, which will already give a fair idea of what variables to include. And also there are other, say for example, PCA, principal component analysis, or the naive Bayes. So based on any of these, we can identify what are the more dominant variables, what are the variables that will have the least effect, so that we can actually come up with only the variables that we want, that will give you a reasonable model for us. So once you identify those, then we can select what modeling technique. Again, we are going to go into more details on the different modeling techniques. Once you do that, then the model execution level, there are 3 aspects that we look into. Model fit, that is, let's say, for example, if we take the regression, then the regression analysis will tell us what percentage is explained by this particular model. So it may say that 84% of the actual dependent variable is actually explained by the independent variables, or 60% and so on. So how good a fit the model is. And then the second is the model will tell us for every variable there will be coefficients for the predictor variables. So that actually tells us how much of an influence every variable will have on the actual independent variable based on the coefficient. And then finally, predictor significance, that actually tells us whether that predictor is that significant, statistically significant to predict the dependent variable. So the predictor significance, so these are 3 things that we will have to look into when we execute the actual model. And then in the case of data modeling, the next would be model diagnostics. In the model diagnostics, one aspect that we can look for is mean square error. What mean square error? Again, in more detail, we'll be covering this, so I'm just highlighting these aspects. In the case of mean square error, it actually tells us, it takes the observation through the model, and it actually compares that with the actual observation, the 2 observations, and then checks the difference between the prediction from the model and the actual observation, and then it will square that value. Squaring is done because then it will remove the direction. That means negative. If it is a negative one, then it will remove that. Positive one, still it will be positive. So by squaring it, then it will only have the magnitude of the actual difference. And then the larger the mean square error, the less valid or the less significant that model is. So we want to come up with a smaller mean square error. And also there are other things like confusion metrics that we will be looking at, which also tells us how good our model is. The last part or final step of the data science process is presenting in automation. Presenting the data, that is how you would present the data, and then automating data analysis, that is in some cases we want to automate it based on the results. So those are the two aspects of the final step 6. Again, there is one whole topic covering this step 6, so we'll be getting into that later. Some of the aspects of this that we have covered in these 3 steps. In the case of the model train cycle, we do an exploratory data analysis first, and then we identify what features to be included in that model, what variables to be included, and then we model it, and then we evaluate the model, and then we again, if the model is not right, then we do an exploratory data analysis, we do a feature engineering, and then we do modeling, and then model evaluation. Based on model evaluation, we may even correct the model. So we may, there's a two-way arrow here. So from model evaluation, we may come back to this. From feature engineering, we may go back to exploratory data analysis, and vice versa as well. So basically, these are 4 concepts that you should be very familiar with: data and exploratory data analysis or data exploration, feature engineering, data modeling, model evaluation, which we will be doing from topic 3. We will be doing this a lot. Okay, so that is our topic 2. So let me just stop my recording.